Hello everyone. I've started setting up the control board for a Bedini type system, and I'd like to show you how I'm doing it. First, it's important to note that the MOSFETs used on this board fully turn on at a gate voltage of about 10 volts. Each transistor gate has a 220 ohm resistor soldered in place. As an output load, instead of coils, I've soldered an LED lamp to the drain of each transistor. This is done purely for visual monitoring. The board is powered by a 12-volt laboratory power supply. The input of the board is fed with 10 volts through a mini resistance box. At the moment, the resistance is set to 4 kiloohms and the transistors are completely off. Now when the resistance is removed, the full 10 volts reach the input. Current consumption is about 160 milliamps and the transistors are fully turned on. Using these switches, I'll be determining the approximate input resistance required for this board. Visually, you can see that 1 kiloohm has no effect on the brightness of the LEDs. 2 kiloohms also show no noticeable change. But at 3 kiloohms, the board is almost completely shut down. On the lab power supply, the current draw is barely visible, less than 10 milliamps. The LEDs are only faintly glowing. So 3 kiloohms is clearly too much. Now let's set it to 2 kiloohms and add another 100 ohms. Visually, nothing changes. At 200 ohms, still no change. 300 ohms, no visible difference. At 400 ohms, the change becomes noticeable and the current drops by about 10 milliamps. Based on this, we can conclude that a potentiometer with a value of around 2.2 kiloohms is well suited for the input of this board. For clarity, with zero resistance, the board is fully on. At 3 kiloohms, it is almost completely off. The range between 2 and 2.2 kiloohms turns out to be optimal. One more thing I'd like to mention. I'll turn off the power so the LEDs aren't shining in my eyes. When I talked about this board in the first video, I left out an important detail. Why the circuit is built in such a complex way, with cut traces, a custom base, and mounted transistors, even though it could have been assembled using point-to-point wiring. The base was made specifically to allow the transistors to be combined. For example, by installing a jumper and tying two transistors together, they can operate as a single transistor. In simple terms, this is an 8-transistor board, and by adding jumpers, it can be used with a coil that has 4 working leads, without any redesign or rewiring. So, if needed, this setup allows for various configurations and adaptations. Of course, this isn't the most ideal solution. It's more food for thought. This step could technically be skipped. However, since the system uses low-voltage transistors, and once fully assembled, there will be no way to adjust it without a connected load, it makes sense to select the resistance or potentiometer value in advance. This helps avoid trial and error tuning. That's all for now. Good luck to everyone.